Okay, so yesterday we went over chemical reactions. We went over the 5 types. Okay, the 5 types are synthesis. Okay, and in the synthesis reaction, 2 elements combine to form a single compound. Do we have a synthesis reaction in the first 5 here on the board? Which one? Number 4 is a synthesis reaction. Okay. The second one we went over was simple decomposition, which is a reaction where a single compound breaks down or decomposes into its 2 elements. Do we have one of those on the board right now? Which one? First one. Okay, then we talked about combustion reactions, where a hydrocarbon reacts with oxygen, and it doesn't matter which hydrocarbon it is, the products are always what? Carbon dioxide and water. Do we have one of those? Which one? Okay. Okay, then we talked about the 2 combustion, or 2 replacement reactions. Okay, single replacement and double replacement. In a single replacement reaction, an element reacts with an ionic compound and replaces the part of the ionic compound it is like, producing a new ionic compound and a new solo element. Which number represents that? Okay. And then the last kind is double replacement, where simply 2 ionic compounds react with each other and the metals switch partners, and we get 2 new ionic compounds, and obviously by process of elimination, that is number 5. Okay, the other things we talked about yesterday were being able to write them in words and balance them. Okay. We only had one reaction type that had special rules for balancing. Which type was it? Combustion. What were the rules? Balance it in alphabetical order. And?
Write it.
The rule of 2. Right? If an even number of carbons you have, balance with a 2 you will. Okay? Always start your balancing with a 2 in front of the reaction if you have an even number of carbons. Will you have to do that to this one? Yes, you will. Okay, what I want you guys to do right now is write those reactions out in words and try to balance them, and then we'll walk through them together as a review. All right, so for number 1 here, okay, we've got 3 nitrogens and 1 oxygen, so we got a molecular compound. All right, so we have trinitrogen dioxide, and it is breaking down into, what's this stuff? Nitrogen, right? Because it's one of the special ones. That's how it looks when it's an element. Okay, plus oxygen. Okay, and remember, we don't put prefixes on elements. Okay, we put them inside of compounds, but never on elements. All right, then we got to balance this thing. So I got to go with my biggest number first, which is 3. Okay, I got 3 nitrogens here in the reactants. I've only got 2 in the products. What number can I use to get them equal? 6. If I can put 6 on each side, then they'll be equal. All right, so what do I need to multiply the reactants by? 2. Yeah, I need to put a 2 here, because 2 times 3 will give me 6. And then what needs to go here? A 3. Okay, how many oxygen do I have now? 4. So what needs to go here? Right, and now it's balanced. Okay, can't reduce those, that's where it is. Questions on the first one? So our second one, we have a single replacement reaction. Okay, it's between calcium and iron 3 chloride. Can't forget Roman numerals just because we're doing reactions, right? It's a common mistake though. All right, here's another common mistake that people make. What's this stuff? Iron. Just iron. Okay, a lot of people will put a Roman numeral beside that because there was a Roman numeral beside it here. When it's an element, it doesn't have a charge, does it? All its electrons and protons are equal, so it's just iron. Okay, and then this stuff will be calcium chloride. Okay, we got to balance this. What should I balance first? Chlorine, present in the biggest number. And we got the same situation. We got 2 and 3, so our lowest common multiple is 6. All right, so I'm going to put a 2 there and a 3 there. That'll balance my chlorines. Putting a 2 here gives me 2 irons. So a 2 there will balance the irons. Okay, and this 3 here gives me 3 calcium, so what needs to go over here? 3. Okay. How many people have done number 3? Okay, I'll give you a couple more minutes to get 3 and 4 done before we look at those. This stuff is actually called, and you'll learn this is one of the first things you learn in Chem 20, this stuff is called hexane. Okay, because it's an alkane, which is a type of hydrocarbon where the number of hydrogens is 2 times the number of carbons plus 2. 2n plus 2 alkanes. Something like that. I don't remember the last time I went over that. But that's where that name comes. Hexane. Okay? Or I would just write fuel. Okay, something like that. Okay. Plus oxygen gives us carbon dioxide and water. So combustion are pretty easy to write because it's always the same things. Oxygen, carbon dioxide, and water. Okay. Now, this one we have to balance alphabetically, but 6 is an even number, so I need to start with a 2. I need to apply the rule of 2 here. Okay, now I'm balancing alphabetically. 2 times 6 is how many? 12. So I need to put a 12 here. There's 12 carbons. Okay. Now I'm going to balance the hydrogens. 2 times 14 is 28. What times 2 is 28? 14. Okay. You'll probably see a pattern developing here. Okay. Now I've got to balance the oxygens. So there's 24 oxygens here in the carbon dioxide, 12 times 2. Okay, so there's 24 there, plus another 14 for a total of 38. Okay, so there's 38 oxygens. What times 2 will give me 38? 19. 19. Because 20 times 2 is 4. So 19 times 2 is 38. It's a lot of numbers. Okay. It's not really hard math, but it's a little bit of numbers. Okay. All right. Questions on number 3. In terms of balancing, I mean, that's about as tricky as a combustion reaction would get. All right. Number 4, we said is a synthesis reaction. We want to write it in words. We have chlorine reacting with lithium. And that gives us, what's this stuff? Lithium chloride. Okay, what should I balance first? Yeah, chloride, biggest number. Any kind of reaction other than combustion, go with the biggest number first. So I put a 2 there to balance my chlorines. Okay, that gives me 2 lithiums, so put a 2 there. Now the reaction's balanced. Okay. Sometimes they're easy like that.
Hey, this is really off topic, but where did you get your shoes?
I ordered them online.
But like, I don't know, they're just I feel like they look like something that you would go like swimming. Like,
Well, they're not webbed.
I like the Pella style.
They're cool.
They're functional.
Yeah.
They actually make your feet do what they're supposed to, instead of having them trapped in a shoe that does all the work for your foot. So it helps keep my knees and back straight because I'm old.
Cool.
I'm getting some Pella shoes.
Okay, how many people have done number 5? Okay, let's have a look at number 5, and then we're going to see what happens when we get the reactions going the other way. Okay, so we got MgF2, okay, which is magnesium fluoride. Okay, ionic compound, reacting with cobalt 3 nitrate. Okay, and I figured that out because nitrate's a -1, and there are 3 of them, so this must be the cobalt with the 3 charge. Okay, and that's going to give me magnesium nitrate. Sorry, I'm writing really small or I'll run out of room. Okay, plus cobalt 3 fluoride. Now, here's something that can save you time. If I start out with cobalt 3 on this side, I'm only going to have cobalt 3 on that side. That's the same for any Roman numeral type metal. Okay, you don't have to figure out the Roman numeral twice. If it's cobalt 3 on the reactants, it's cobalt 3 in the products. Don't try and figure it out twice. Okay? All right, now we got to balance this. What should I balance first? I can do nitrate or fluorine. They're both a 3 at one point in the reaction, so it really doesn't matter which one I go with first. Okay, I'm just going to go with fluorine because it's first. Okay, so there's 2 on this side, 3 over there. Lowest common multiple is? Okay, so I need a 3 here and a 2 here. All right, when I put the 2 here, that gives me 2 cobalt. So now I got to go back over here and put what here? A 2. Okay, how many nitrate does that give me? 6. Okay, what do I need to put in front of this? Okay, does that make my magnesium work out? It does. All right, questions on any of those? Okay, so now we've done a bunch where I give you the formula reaction or the real chemical reaction and you had to write out the word reaction and balance. Okay, now number 6 goes the other way. And these are a little bit more tedious because you got to write the formulas. If you don't get the formula right, what else won't you get right? You won't be able to balance it. Or if you do, the numbers won't be right. Okay? It is really important that we are able to write formulas correctly. So we're going to start out with copper to nitrate. So copper, the Roman numeral tells me to use 2+ in my drop and swap, and it's with nitrate. NO3, which is a 1-. So when I drop and swap, the 1 will go here, and on the brackets with a 2 outside the brackets. Okay, right for that one. Okay, it's reacting with magnesium. Just magnesium. It's going to form magnesium nitrate. So that's a 2+. Nitrate's a 1-. So when I drop and swap, I'll need brackets and a 2. Okay, and copper, metal, which just means copper. All right. So as I'm writing out this reaction, I'm doing the drops and swaps of my ionic compounds. Okay. The other thing I want to check for is, are any of these special elements that need 2s or 4s or 8s beside them? Okay, are there? No. Okay, I don't have any non-metals. Okay, I don't have any of those, so I don't have to worry about that. Okay, what kind of reaction am I looking at here? Single replacement. I have an ionic compound reacting with an element, so that means single replacement. What should I start my balancing with? Okay, I can start with the nitrate. I have 2 nitrates over here and 2 over here. Is it balanced? Okay, I have 1 magnesium, 1 magnesium. Is it balanced? Okay, copper, copper, 1, 1. Okay, already balanced. Okay, so I don't have to put anything else on that. All right, I want you guys to try number 7. This is Dodecane, but you don't need the name because it gave you the formula. Okay, so you're going to write out the reaction here, identify the type, and balance. So for number 7, we've got C12H26. Okay, big numbers for sure. Reacts with oxygen gas, O2. Okay, and like in all reactions of this type, produces carbon dioxide and water as products. So this is what kind of reaction? Combustion reaction. Okay. Special balancing rules. Balance alphabetically in the rule of 2. Do I need both? Yes, 12 is an even number. All right, so that's going to make all the numbers even bigger. That's okay. 2 times 12 is 24. I need a 24 in front of my carbon dioxide to make sure I have the same number of carbons on both sides. Okay, 2 times 26 is 52. Okay, and 26 times 2 is 52. All right, so now I've got my hydrogens balanced on both sides. Now I need to look at my oxygens. 24 times 2 in the carbon dioxide is 48 oxygens. Okay, plus another 26. Okay, is going to give me 72, right? 74, sorry. Yeah, 74. So I got 74 oxygens that I need to get from this O2, right? So that's going to mean I need 37 of these, yeah? I'm doing math in my head, which is a bad idea. Okay. Pretty sure 37 times 2 is 74. Okay. Everybody follow me on that one? How many people are done number 8? Okay. Let's do 8 and 9 for now, and then we'll go through those and see how it goes. Actually, you know, I'll put all of them out there. Okay, if you can get all 10 done, okay, great. I'll give you a couple more minutes and we'll go through 8 and 9, and then we'll see about 10, see if we run out of time or not. Okay, so for number 8, we got lithium nitride. Okay, so Li, which is a +1, and nitride, which is a -3. So when we drop and swap, we're going to have Li3N. Breaks down into nitrogen and lithium. Okay, what do I need to check for here? I have a non-metal as one of my products. Not for Roman numerals, but for...
Like when they have like, they come in pairs of 2.
Right, see if it's one of the, we just call them special elements. See if it's got a 2 or a 4 or an 8. Is nitrogen one of those? Yeah, it's a polyatomic element, right? So N2, right, is what we have to have there. If you forget that, it's downhill from there for you on a question like that, because now you won't balance it correctly. Okay, so now that I have that written out, what kind of reaction does it look like? Decomposition, yeah. It's one compound breaking down into 2 elements. Okay, so it's decomp. Okay, and then we gotta balance this thing. Now it looks like I should start with lithium, but if I do, I'm just gonna end up erasing my numbers. Why? Because if I go over here and put a 3 in front of lithium, okay, now I'm gonna look at my nitrogen and go, oh, wait, there's 2 of them. I gotta put a 2 in front of this. Okay, and that's gonna happen sometimes. This start with the biggest number works like 95% of the time. But once in a while, you're gonna run into one where, oh shoot, that number was wrong, I'll have to change it. Okay, and that happens. So I need to put a 2 there, and then I need to erase this 3 here. And I have to put a 6 in front of that instead. And now it's balanced. Okay, how many people are done number 9? Okay, so look at that one too. So for number 9, I have hydrogen sulfide. So H with S. This is a +1 and this is a -2. So when I drop and swap, that's H2S. Reacts with calcium hydroxide. Ca, 2+, OH, 1-. So when I drop and swap, brackets have to go around that. That's going to produce calcium sulfide, 2+, 2-, so that one's good the way it's written, plus hydrogen hydroxide, or water. Okay. Anytime I have water as part of a replacement reaction, double or single, I always write it like this. In a combustion reaction, I write it as H2O because it's easier to track where the H's and O's come from. But if I've got a replacement reaction where I'm going to be putting hydrogen and hydroxide together, writing it this way is easier to track where the pieces come from. Okay, because I know this OH that's in the water came from here, and it's easier for me to balance. Speaking of which, I probably want to start with that because it's the biggest number, 2. So I'm going to go back to here and put a 2 in front of that. Does that also balance my hydrogens now? Yes, because I have 2 hydrogens over here. Okay, and then I have 1 calcium and 1 calcium, 1 sulfur, 1 sulfur. So the only number I needed was 2 in front of water in order to balance that. Okay, how many people are done number 10? Okay, let's have a look at that one too. Okay, so for number 10, I have phosphorus. Special? Very. P4. Okay, it's one of my polyatomic elements. Reacts with oxygen. Is oxygen special? Yes, it is. To produce triphosphorus dioxide. P3O2. Okay, what should I start with? Phosphorus. Okay, it's the largest number. What's the lowest common multiple of 3 and 4? 12. Okay, so I'm going to put a 3 here to give me 12, and what here? 4. All right, when I do that, it gives me how many oxygens? 8. Okay, what kind of reaction is that? Synthesis. Okay, so we're going to be working on this for a while. Obviously, going from words to formula carries a little bit more kind of weight to it. You got to make sure you get all those formulas correct. Look for your special elements; those are important too. Okay, so we'll be working on that a bit more tomorrow. Okay, if you guys can mask up and get your desks washed off, that would be awesome.